Okay, so in today's class, as what we said, we're going to review the answers for the test number 1. I hope you all get the grade you desire. But if you're not, that's not the end of the semester, so you still have time to or have chance to catch up. Okay, and in order for you to have a better grade in the final exam, you need to know what you have done wrong about the test questions. So please review today's video to make sure that you can get the right answer for each of the questions. Okay, let's get started. So the first question in the test. So it's talking about the 7 principles. Okay, so we said you at least need to know what are the 7 principles for engineering economy. And then here I listed several of them. Develop the alternatives, use a common unit of measure, consider all relevant criteria, make risk and uncertainty explicit, revisit your decisions, and what. Okay, so you want to see whichever of these 4 options, whichever is correct for as a fundamental principles of engineering economy. Okay, so focus on the opportunity cost. That's not one of the principles. Focus on the differences. Yes. And always use a top-down method to estimate the cost. That's not a principle. Use a consistent viewpoint. Yes. So that's the 2 answers. Okay. So for this question, you're going to have 2 answers. The second question, what cost is the additional cost that results from increasing the output of a system by 1 unit? So 1 more additional unit, what's the additional cost? That's the marginal cost, sometimes also called incremental cost. Okay, and if you read the book very carefully, you will see the incremental cost instead of marginal cost. But in the world of economy, these 2 are used interchangeably. And there are some very specific cases where they are a little bit different, but that's too much for our class. So we will just use these 2 words interchangeably in our class. Okay, next question. What statement about opportunity cost are correct? Opportunity cost, okay? It is a benefit that is foregone by engaging a resource in a chosen activity instead of engaging that same resource in a foregone activity. Yeah. So when you have different options, you choose one, you means you couldn't do the other several options, which means the potential for gaining more money if you do the other options is gone. So that's the opportunity cost. So of course, the first one is correct. It is the money or time spent as a result of a past decision. Okay, it's talking about past decision, which we cannot do anything about that. So this is a sunk cost. This is not opportunity cost. It is the variable cost for 1 more unit. No, that's the marginal cost. It is the total cost divided by the number of units. No, that's the average cost. So for this question, you only have 1 answer correct. Select the right statement about marginal cost and average cost, and you can choose more than 1 options if needed. So average cost is the total cost divided by the number of units. That's right. Marginal cost is the variable cost for 1 more unit. That's right. Marginal cost is always the same as average cost. Always the same? No. Marginal cost and average cost could be different. That's right. Remember that we have shown a table listing the the cost for each one more unit. Remember that? And then we calculated the average cost and the marginal cost, and we compared them, and we found the conclusion that they could be different. And usually, in many cases, they are different. Okay. Question number 5. In engineering economics, the relationship between price and demand could be depicted by a chart in below. So that's the chart. That's the angled line we talk about, right? It's going downward. From this chart, it can be concluded that when price increases, so when price going up, what happened to the demand? Okay, so if you got higher price, your demand is gonna be very close to zero, which makes sense. If that product, cell phone, maybe very expensive, then nobody wants to buy it because we have cheaper ones. We have cheaper options. So for this question, when the price increases, demand will decrease. All right, now it's all about the calculation problems. So the first one is to use the relationship between P and D, price and demand, to calculate a bunch of useful concept. Okay, so let's read through this statement. A large wood products company is negotiating a contract to sell plywood overseas. The fixed cost that can be allocated to the production of plywood is 900,000 per month. So that's the fixed cost. So C, capital F. The variable cost per unit is 131.5. So that's the C, lowercase v. The price charged will be determined by the price equals to 800 minus 0.05 times demand. Okay, per unit. So that's the relationship between P and D. Based on a statement, finish question 6 to 16. Okay, so we have learned that the relationship between P and D is P equals to A minus BD. Okay, that's the equation we know. And we also define the fixed cost as CF and the unit variable cost as C lowercase v. So based on the statement of the problem, what are the right values for A, B, C capital F, and C lowercase v? Okay, so if you write this given relationship as P equals to 600 minus 0.05 D, and compare that with P equals to A minus B D. So you can see that your A is 600, your B is 0.05. Okay, so A is 600, B is 0.05, no negative sign. Okay, and then CF is 900,000. C lowercase v is 131.5. Okay, this is given here and this is given here. So just check the options. Okay, so CF, so this is the correct answer. And then the question is, in order to find out maximum profit, okay, what types of demand you need to find out first? Okay, for maximum profit, you want to go with the D star, which is the optimal demand. So D star, that's the right one. What is the right formula to calculate demand you selected in question number 7? So what is the formula for D star? And this is the one, very easy. Now, what is the value of the demand associated with the maximum profit? So once you choose the D star equation, you just calculate. So D star is what? Is A minus C lowercase v over 2b. A minus C lowercase v over 2b. So what is A? A is 600. CV is 131.5, right? and 2 times b is 0.05. What's this? This is 4,685 units. That's the optimal demand. That's the demand you want to reach to get your profit, get your maximum profit. So this is the answer. What is the right formula to calculate profit? Profit, of course, this one, very easy. Then what is the maximum profit? So we said if you want to calculate the maximum profit, you're gonna use the A, B, C, F, C lowercase v, and the D star in that equation. Okay, so that equation is, you copy this. So your profit, if we want to have maximum profit, you're gonna use minus B, D, but you want to use the D star to the power of 2. Okay, and plus A minus C lowercase v times the D star. Okay, just replace the D with the D star. And minus C capital F. Okay, and then you just replace these letters with the values. So minus B is 0.05. And D star, you just calculate it out. It is 4,685 to the power of 2 plus 600 minus 131.5, right? Times D star again, 4,685. And you want to minus the 900,000. Okay. So this term, you will get minus 109,746 1.25. Okay, and then this, you will have 468.5 times 4685. Okay, and then minus 900,000. The final result is 197461.25. So 1974, that's going to be your answer. Okay. And next question, the company wants to know what is the range of the demand they can gain profit. So break-even points. You want to calculate your break-even points. So this is going to be the equation, long one. And now, what is the lower bound? What is the upper bound? So what is D1 prime? What is D2 prime? That's the question. And so, well, the tricky part is not about like the equation, it's about how do you calculate it. Okay, so the D prime is a long equation, which is A 600, right, minus CV. CV is 131.5, right, plus minus something in the bracket, okay, to the power of a half. So what is in the bracket? It's first it's A minus CV to the power of 2 minus 4 times negative B times negative CF. Okay, and then all of this over 2 times negative B. Okay, like what I said, you always want to start with the calculation in the parentheses and then the bracket, okay, and then the bar. So first, what is in the parentheses? Okay, so we're gonna calculate this and this and this 3 first. Okay, so 600 minus 131.5, which is 468.5. Okay, plus minus bracket 468.5 to the power of 2. Okay, minus 4 times negative 0.05 times negative 900,000. That's gonna be 180,000. Okay, and then over negative 0.1. Okay, and then we calculate this. Still copy this, leave it there, and then calculate what is the 468.5 to the power of 2. That's gonna be 219492.25 minus 18,000 to the power of a half. Okay, over negative 0.1. And then you want to calculate this. Okay, so still you have this bar, negative 468.5 plus minus. Okay, what's that in the bracket? Let me get my calculator. Wait a minute. Okay. Okay, now I have my calculator, and then we need to calculate what is 219492.25 minus 180000. Okay, so that is 39,492.25 to the power of a half. Okay, and then what you want to calculate is this. A second. Okay, so negative 468.5 plus minus so the square root of this big number in the bracket is gonna be 198.73 over minus 0.1. Okay, so from now you can have two values out of this one single equation. Okay, so one value is negative 468.5 plus 198.73 over negative 0.1, and the other is negative 468.5 minus that 198.73 over negative 0.1. Okay, so the one above, the equation above, will give you the lower bound of the break-even points of the profitable range. Okay, so that's gonna be 2697.7 dollars, and then the one below will give you the upper bound, which is, I will write it here, 672.3 dollars. So for this question number 13, the lower bound is gonna be this one, and question number 14, the upper bound is gonna be this one. Okay, so if you don't get the right answer for this time, please watch this video, on this slide, how do I calculate through, and then I wish you can make it right in the final exam. Okay, all right, wait a minute. So question number 15, if the company could achieve the maximum profit, what the price will be at that time? Okay, so if you're using D star for your maximum profit, then how do you get the price of that demand? Well, I got a hint here. So the hint is that you can use the equation of P equals to A minus BD to calculate that price. You just need to use the A, the B, and the D star in this equation. So P is A minus B times D star, because you're looking at the price when you got the maximum profit. Okay, so the A is 600, B is 0.05, D star is what we just calculated for D star is this one. Okay, 46.85. So 46.85. Okay, and then the answer for this is 365.75. So this is your answer. So if you can sell your product at this price, you would expect a demand of 4,685 units, and at that point you're gonna have your maximum profit. Okay, so next question. Oh, that's another whole new problem. Okay, so question number 16 is talking about purchasing and installing of a boiler. Okay, so the price, the index of the boiler is keyed to 1988. So which means the index of that boiler in 1988 is 100. Company X, Y, and Z installed a 30,000 pound per hour boiler for this price in 2005. So we know the cost in 2005 is this. When the index had a value of 489, so index I bar of 2005 for that boiler is 489. The same company must install another boiler of the same size, okay, in 2020. the index in 2020 is 618. So I bar in 2020 is 618. And so what is the cost in 2020? So this is about the DAX, the price index. So you want to choose the indexing method. And the equation for indexing method, this one, easy. So what are the correct values of variables needed in the estimation? So we already listed here, okay? So the cost for 2005 is 320,000. And you also want to know the I bar of 2005, which is 489. So this is going to be your correct answer. And of course, the I bar in 2020 is 618. That's given. So now, what is the cost of the new boiler? You just calculate with the equation. So the equation is Cn equal to Ck times I bar N over I bar K, right? And Cn is the price of the product of the equipment in a year which you don't know. I mean the unknown, with the unknown price. Okay, the year with the unknown price. So that year is gonna be your C 2020 because you don't know the price. You need to estimate it. And the CK is K is the year when you know the price. Okay, so CK is C 2005. So the index above the bar is the index of that unknown year. So it's 2020. And then the index beneath the bar is the year you know the price. Okay. So C 2005 is 320,000 given in the statement. And I bar 2020 is 618. I bar 2005 is 489. Okay, so the answer is 404,417 and 18. Okay, so that's your answer. Next question. If given that to build a 2-lane highway, the cost per mile is 6.2 million per mile, that's a unit price. What is the estimated cost for building such 2-lane highway for 100 miles? Okay, so you're gonna use unit method. 6.2 million per mile times how many miles? 100 miles, which is 620 million US dollars, which is a lot. Okay, that's your answer. Suppose your construction company needs to generate a cost estimate for building a house. What is known is that the house consists of 3,000 square feet. Okay, the house size. 3 porches. 3 garage. Using a unit factor of $90 per square foot, 10,000 per porch, and 7,000 per garage for estimation. So what is the cost for this price for this house? So you got 3,000 square feet and you got 90 per square feet. Okay, so that's the cost for the floor plan. You got a plus, you got a 3 porches, and each porch you need to spend 10,000. So that's the cost for porches. And plus you got 3 garages, and each garage need 7,000. So that's your garage cost. So in total, you're gonna spend $321,000 for this house. Okay. Next question. Suppose that an aircraft manufacturer desires to make a preliminary estimate of the cost of building a fossil fuel plant. The size of it is 500 MW. Okay, for assembly some new type of aircraft. So this is a size for a plant. It is known that a 200 MW plant costs 300 million now. Okay, so for the 200 MW plant, the cost is 300 million. Okay, so this is the size, this is the cost. And then for the 500 MW plant, what is the cost? Okay, and the cost capacity factor, which is the X, is 0.79. Okay, so for this type of problem, it's talking about building a bigger size of something based on the price known for building a smaller size of that similar thing. So this is absolutely power sizing method. And the equation for that method is this. So now let's just calculate. So ACA is gonna be the unknown price. Okay, so that's for the 500 MW plant. Is the C, which you know the price. This is the cost for the 200 MW plant times SA, so the size of the 500 plant over the size of the 200 plant to the power of X. Okay, so C 500 MW plant, the cost equals to 3 million times a ratio which is 500 over 200, okay, to the power of 0.79. So this is gonna be 618.72 million US dollars. So this is your correct answer. Next question. Okay, now we have a student team. The team is learning to design and build Formula cars. The time required for the team to assemble the first car is 100 hours, and their improvement or learning rate is 0.7. So what is the time cost for the team to assemble the fifth car? Well, it's very obvious, talking about learning rate, so it's a learning curve method. Okay, and the formula for this learning curve method is gonna be this one. Okay, so this is 2. And now what are the values of the variables you're gonna use in that equation? Okay, so you need to use, because let's just write that equation here. So ZU is K times U to the power of N. N is log learning rate over log 2. Okay, so here you want to know what is K. K is given as 100. Okay, so these two both right. And what is U? You want to know the fifth car's cost, so U is gonna be 5. And S is the learning rate, which is 0.7. And N is gonna be log 0.7 over log 2. So this is your correct answer. And now it's the time to calculate. So z u equals to 5, so z5, the time cost for building the fifth car is k is 100 times u is 5 to the power of n equals to log s is 0.7 over log 2. Okay, and if you calculate, this is gonna be negative 0.51. So z5 is 100 times 5 to the power of negative 0.51, which is gonna be 44 hours. So this is your correct answer. Okay, so I guess that's all for today's class. So so if you got something wrong, you'd better go over these slides and then practice again, because in the final exam you're gonna see similar questions again. Okay, so just make sure you understand all the calculations and equations. Okay, all right, so I'll see you next time. Bye.